I would like to talk about the challenges of protecting and securing popular AI and machine learning models in a hardware-assisted trusted execution environment, while referring several instances of attacks on popular framework of machine learning models. We can also deep dive into the threats and risk of machine learning in modern mobile devices, from API extraction threats to intellectual property protection. I will detail some attacks about the graph neural network and large language model as well.
Welcome to TALK.CYBERCNI.fr.
Bienvenue.
Welcome to TALK.CYBERCNI. Today we do not only have the first edition of 2025, but it's actually also the 42nd edition. And those knowing Hitchhiker's Guide Through the Galaxy, for instance, they know the importance of this edition. And therefore I'm super happy to welcome Soumya Banerjee today again for a super interesting talk. So the last time we heard about him was 3 years ago, and the series was about lattice-based crypto, if I remember correctly. And today we have something super interesting about the sixth sense for AI algorithms, challenges on confidentiality, trust, and security for mobile devices. And before we come to Soumya, before I introduce him, those following this series for a longer time know it already. I'll tell you a bit of the modalities, how you can interact, and so on. The series, you all know it, is about getting to know the different facets of cybersecurity. Last time we talked about fake news. Next time we'll talk about patents. And so AI, obviously super important. Recently, just last week, the Chinese DeepSeek model was published, which is quite impressive from the performance. The stock market was crashing about it. So this is the big thing in our time right now. And so therefore, a super timely talk. And really thanks to Soumya that we have such a nice topic today. So how can you interact? As always, we have the second screen. The second screen is Slido. So this is a tool where you can scan the QR code that you see here, or you go to the website slido.com or sle.do/talk42, or you enter the code talk42. You know it as always. And once you go there, you can put your questions, you can follow, you can upvote and downvote questions. And so it's a very good idea. We'll use these questions for the discussion in the second part of today's edition. And as always, this will also be super interesting. Okay, so this from the technical perspective. So now let's introduce Soumya. So Soumya Banerjee is a Senior Vice President for Innovation at TRASNA Solutions Limited. And he is also a senior researcher at the University College Cork in Ireland. And he has been specialized with computational intelligence, machine learning, security, and blockchain across smart and connected environments for almost 2 decades, and visiting both research and teaching. Prior to TRASNA and UCC, he was invited research professor at CNRS INSA de Lyon in France, at TU Ostrava in Czech Republic, at the CNAM Cedric team in Paris, and still is an adjunct senior researcher at INRIA IVA Paris. He has more than 150 peer-reviewed publications, IEEE, LSVA, Springer, and so on. And he has a European patent on bio-inspired algorithms from 2009 to 2011. And with all this huge background, I'm looking forward to hearing about the topic. And with that intro, I directly hand over to you, Soumya. We're looking forward to your talk.
Thanks, Mark, for the nice introduction, and thanks for the invitation. You have invited me for a super interesting talk, as you mentioned. I think you can see my screen. Everyone can see my screen. Yeah, is okay. Yeah. So let's start together. The most interesting topic and the buzzword of today, that sixth sense for the AI algorithms, challenges confidentiality, trust, and security for mobile devices. So I am representing TRASNA Solutions Limited, as Mark mentioned. So before going and jumping into the topic in details, I will just present a kind of overview and agenda what I will be covering so far in the topic. First of all, we will introduce the genesis of problem statements, because whatever we mentioned the name and in the block of the slides, that was the initial curtain raiser, you can say. So normally we have to extend the problem statement in details. Then we will try to cover some of the background of the initial inputs, because we will be mentioning the hardware also, because part of this coverage will also touch the hardware part, that is the trusted execution environment. So we will cover those points. Then we will present some facts and instances, because these are essential to elaborate our problem statement. And then we can jump into the machine learning pipelines where the attacks can be prohibited. Then we will introduce trustworthy AI, which will define by ourselves theoretically and from industry perspective. After that, we will introduce the AI and ML attacks on device, because that's the age of age AI and the tiny ML. And then after that, following this discussion, we'll go for the risk on generative AI and LLM, especially on the DeepSeek model. Everyone, that last week it is a big release and big noise entire globe. And then we'll give some idea of the machine learning model encryption on the devices, some futuristic innovation which we are doing from TRASNA, and personally I'm also doing, and some takeaways after the talk. So before going into the details, I'll give you a short description of TRASNA. It's a European-based IoT technology lead. It provides fully integrated connectivity, hardware and software solution. It also completes the IoT lifecycle management with SIEM, eSIM, and connectivity. And then we have the 200 plus telcos and DAMs from the 80 plus countries all over the world. This company is having 25 years of experiencing in technical hardware, software, and system on chip solutions, and is also an active member of GSMA. However, this company, whatever this company is doing, that also blended with a lot of innovation, which I am just leading the innovation and research side for TRASNA. And we have AI and blockchain and private blockchain development on chip itself. So we have blending of software and hardware, and we have also backing up the co-design factors. So let's do the first part, the genesis of problem statement. Today we are using all AI platforms, machine learning platforms. Everyone is knowing this buzzword, what is ML and what is AI. But we don't know how to improve the AI solutions and security solution for the AI and machine learning, specifically the privacy solutions. And we also don't know much about that how much secure and trusted the AI systems are. Maybe in the devices, maybe in the cloud. But today we'll be just describing much details on the device part, on the hardware part, and we'll touching the part of the cloud or part of the broader application apart from the devices. So as I told you that I'll be giving some initial input, let's go back a couple of years before, not much back, but it can be 2022 or 2020, before the COVID began. So it was a trusted execution environment. Everyone will be knowing that. What is the gist of TE? Gist of TE is that it's a kind of isolated execution environment. It can be protected or sealed, or you can say it is completely secured. And it is also have an ability for secured remote attestations. So at the end of the day, what is desirable for a trusted execution environment, why it was so popular at that time, before 4 years or 5 years down the line, to protect our assets of the system if the software part is compromised. So I think this is the main buzzword which actually attracted the people all over the globe about the trusted execution environment. And if you can see the research and the background of it, you can say that there are plenty of availability of resources, like from 2019 keynote I mentioned here of CCS. Then you can go through the 2022 book. There is a famous book of the publication platform, the Security for Mobile Devices. So you can see that these all are integrated into a kind of trusted execution environment and trusted computing block. And most importantly, there was one paper which was becoming phenomenal at that time. I think it is 2022, and you can find it on the Xtreme. That is called the hardware assisted memory protection feature. That means you can protect your memory stealing, and it can be used as hardware and software tool as well. So broadly, this sense of trusted execution environment, you can see it that it has begin more than 5 years or 6 years or 7 years down the line before AI sparkled into reality. So if you are going back in the details, little bit details, foundation details, then there is trusted computing base. There is a TCB or trusted computing base, and you can see my screen that there are different parts. So fundamentally, the part of the firmware which is called SMM, that is called system management mode, and which is also defined as a runtime BIOS, and it actually gives the security protection for a software running in confidential computing environment. So that means this SSM firmware, if you can see that this SSM firmware is actually giving some kind of a good buzzword, then at the same time what is happening is that with SSM, you have the hypervisor, you have the gateway, you have the app. So everything is configuring the entire trusted computing base, which is a basic and nucleus component for your trusted execution environment. So as I mentioned you, the trusted execution environment is a hardware environment, and it is backed up by enough software and protection unit. So let's see what are the different criteria of doing these things. So one thing was, at the same time, there was a potential solution that for this kind of system, that I told you that it can also offer the remote attestation. So the people are trying to use homomorphic encryption. Homomorphic encryption is a kind of encryption technique. It's not related with the AI, but it's a kind of encryption technique, specially used for the quantum machine learning or quantum environment. They use to have some kind of private key and public key combination in terms of mixing it in an environment where you can make it remotely attested, or you can make it uh, make the identity verified remotely. So what happens is that this kind of solution for the hardware block for the mobile devices, giving us lower convergence of the software. So solution was something like this, that we have to build a TE, that is trusted execution environment, with a very small TCB, so that the entire trusted execution environment you can carry with your mobile devices, with your laptop, with your tab, with your iPad, everything. The idea is that it should be small, it should be device specific, and it should not create entire great latency on the system itself. So what happens is that in the market there is some protection granularity comes, and trusted execution environment and trusted computing block are having different size as well. So you can see some traditional system, there is called ARM Trust Zone, and most popularly the Intel SGX, which is called Software Guard Extensions, and Trust Domain Extension, TDX and SDX. These are the couple of, you can say, couple of instances or industrial use cases which have been put forward to produce the small size of trusted execution environment which can fit with your device to protect your device software not to be compromised, right? So by this kind of input, we can identify that trusted execution environment was a foundation model, and after that the AI and machine learning algorithm has been sprinkled into reality. So there is a huge kind of proliferations in machine learning architecture, machine learning model, algorithm, convergence, etc. So obviously, the trusted execution environment and trusted computing block was not so fast to catch up the speed how the AI and the machine learning have been really great, made the revolution. So what happens? There are some serious facts which have been happened so far. You can also find it from Google. You can see first is the North Korea, which has used Western language LLMs to generate fake resumes and profiles to apply for thousands of remote work jobs in Western tech companies. And surprisingly, these LLMs have been hacked completely. And once hired, these workers, usually laptop firms in China or Russia that are supervised by a handful or individuals, use some remote access tools to gain unauthorized access to corporate the infrastructures. So that means trusted execution environment was there, trusted computing block was there as a foundation, but that was not able to meet up the need for the LLM, which is been compromised so far by different kind of hacking systems. Similarly, there are different application and instances which has giving plausible examples of AI targeted phishing. So you can have some kind of example that 60% of participants in a recent study fell victim to AI generated spear phishing content, a similar success rate compared to non AI generated message by human experts. So you can see those LLM models which are having a buzzword today on your laptop, on your device, on your mobile, that can be effective false alarming to you in terms of hacking the systems, in terms of malicious attempts to manipulate the information of your system. So you can go through these papers if you're interested. There are very recent findings of two papers, which we are in, especially in the 2024, the last one, the second one, devising and detecting phishing emails using large language models. It has been published in IEEE Access. So you can identify these kind of instances have been already made a kind of potential alarming to the researchers. So what will be our objective? Objective should be that, as I told you, that machine learning and AI model have been given a revolutionary breakthroughs nowadays, which are not being captured by all the hardware or all the co-design factors. So normally, there are three things which are essential right now. One is that there can be a model stealing. You know, there are machine learning models, there are machine learning frameworks which can be stolen from your device or which can be stolen from the developer side. Then there should be some kind of appropriate adversary model, which we must identify what are the good appropriate adversary model, secure adversary model, which can be used and deployed. And then at the same time, we also deploy defenses with the multiple type of attacks. So normally and eventually, the attacks nowadays are not coming for the AI and mobile or AI or machine learning algorithm on the devices in the same directions. It can happen in multi directions. So our defense strategy, our mechanism to protect our algorithms and software or hardware should deploy the multiple facets of these kind of defenses. So our concern, what is our concern? First concern is that why should we care about confidentiality? Everyone knows that data is very essential, it is very crucial. It's not only the health and related data, but personal information as well. Then what extent can machine learning model be stolen using only their prediction APIs? So we must know that if we are using machine learning, if we are using machine learning on mobile devices, machine learning on hardware, we must know what extent the ML machine learning models or machine learning foundations or frameworks can be stolen, and what approaches can be used to counter model extractions. So suppose your system has been compromised, so what should be your strategy or algorithm to protect your mechanism or to guard your mechanism? So first of all, that if you can see, AI will be more verticals. So I am just showing you till 2027. You can see the market is going up, up and up. So I am not too sure that what it will reach and what should be our last destination. As Mark mentioned in the introduction, that I am working for more than 2 decades. Yes, I'm working with AI more than 2 decades. At that time, AI was known as computational intelligence. So in computational intelligence market, it was not so far because people are not using it. Right now, everyone is using the AI in devices, in systems, in mobile, in cloud, and everywhere. So the kind of proliferations or kind of enhancement of usage of AI are giving leaps and bounds. So you can see the graphs are going and going. Based on this architecture, now we can understand, or we must understand, that what should be the propositions and what are the possibilities where the machine learning pipeline can be stolen or can be compromised. first of all, that we must see these kind of diagrams, that we have registered owners, we have a data set. Of course, we need a data set to train our model. We have a trainer and we have a machine learning model. We have some API instances and we have a client. Now, question is that where is the adversary or target identified? If the target is identified, what is the adversary? You can see my graphic scheme that it shows that this is the target adversary and it creates an attack. So what happens here, I'm going back again, it make a kind of evasion attack. This attack is called evasion attack. Evasion attack is an attempt to make a model output incorrect results by slightly perturbing the input data. You can see we have not given a kind of model stolen here. We have not attempted any kind of great threat here, but we have just made a kind of modification in the training data, and quite obviously your result have been impressed. So these kind of systems are quite dangerous and quite crucial, and slowly but steadily it can taken care the control of your system. So if you want to get a details, then you can see the two papers which have been followed here. Although these papers are quite old, but which is quite phenomenal. The first one is the Intriguing the Properties of Neural Networks, ICLR 14, where it has been published. Another is the KDD 2204, that is the Adversarial Classification of the different kind of attacks. So these are very primitive things that if you can just modify your training data little bit, slightly and partially, your entire output can be impressed or can be compromised. So what happened that there can be a malicious client which can just disturb your model confidentiality. So what is model confidentiality? You see that in this scheme, what happens, there is a email model and there is an inference service provider API and there is a client. So what happens that the gray color is the stolen model. The model has been already stolen. So what happens here that you cannot do anything because the entire model is stolen. The first step was to bifurcate your input data so that you can be deviated from the exact output. Now your exact model has been stolen. So what happens here that these are the two instances I am showing you, and these instances are showing that there are enough possibilities that whatever the machine learning model and framework you have started with your systems can be compromised at any point of time by perturbing your input data in terms of training, or maybe the entire model could be stolen step by step. So what are the different kind of verticals or different kind of direction where these kind of attacks can be uh, prohibited? One is that poisoning. Poisoning is the thing which I just mentioned you, and is the model stealing which just we mentioned. Then model inversion. This is another crucial approach, that whatever the model you have been targeted or you have been fixed, that has been inverted. Then backdoored ML, that you have done some kind of front end machine learning pipelines and that has been completely backdoor by a backdoor ML which has been given maliciously to your systems. Then adversarial examples, there are different kind of adversarial examples. Then malicious ML providers recovering training data, that is another big use case for this trustworthy AI. And of course the entire supply chain of the machine learning can be attacked. So if you are approaching to build up or to consolidate a trustworthy AI model, these are the few points. I can mention many others. People can also put down other points as well, but these are the main verticals where we have to emphasize. So in terms of finding this thing, we have two efforts here. One is called that what is the defense against the model stealing, because people are not sure that model has been stolen. So first of all, that model has been stolen, it can be detected or it can be extracted reverse wise. So if the model has been stolen, it can be extracted, don't worry about that, or it can be detected that model has been stolen. And these kind of work have been supported by a good example of simulations. You can also have a look on these papers, increasing the cost of model extraction with calibrated proof of work. So this is a good and nice work which has been published by ICLR. and they showed that how the what is the cost of model extraction. Of course, there is a cost if your model has been stolen, and if you have to extract back to your system, that could be a cost. But to my practical experience, if the model has been stolen and model you have to extract back, then you cannot make it 100% I mean reverse. So you have to compromise certain amount of losses in terms of extracting the model. So of course there is a question that what should be the desirable business model. In the desirable business model, we have a kind of model ownership resolution. So any machine learning model, whenever we want to bid with the machine learning model and develop the machine learning model on the devices or even in the cloud, we have two things in common. What is called watermarking, and another is called fingerprinting. So these are the techniques which will give you a consolidated security. If there is a system which are attack prone, or there might be possibilities for different kind of attacks from different malicious users. So watermarking facts and possibilities, there are some kind of possibilities. One is the possibility that training the victim model, embed watermark while training the potential victim model, choose incorrect labels for a set of samples, and cannot resist model extraction. So you have to make a kind of watermark while training the victim model. And another is called embed watermark in the inference API. So you have to create a kind of API, inference API, and this inference API is not an open API. We have to make a watermark on the API, so that if or there is some instances the model has been stolen or had been compromised, the watermark can save you out for the extraction. So you can say it is a kind of reverse engineering to protect the attack, or rather to reverse or to extract your compromised software or your compromised portion of the machine learning model from the attackers. But at the same time, there are certain amount of other techniques. Fingerprinting is one of those other techniques which can make a kind of good distinguishment between configurable adversarial example and other transferable ones. And there is called data set inferences, and there is called grove. So these three things I should make and emphasize. Grove is a graph neural network embeddings. So in graph neural network, embedding is a property which could be given as a owner verification. So that means if you are the owner of the graph neural network, and if you are using a grove or embedding techniques, so embedding techniques give you a prompt of security that this graph neural network has been owned by you. That means there is an identity verification itself if you are using embedding in graph neural network. So graph neural network can be secured if there is a possibility of stolen the graph neural network, if there is a possibility of malicious attempts on the graph neural network, you can always integrate embedding on this, which can protect your models. Then there is data set inference, because there is a susceptible false positive and negative under conditions. This is also DI, it is called DI, and this DI or data set inference also making a huge impact on the machine learning models, especially the models which are very popular in the cloud side, like support vector machines or logistic regressions. So they have susceptible to false positive and negatives under certain conditions. So we need to create some conditions for these inferences, and this DI, the data set inference, can give you a protection if there is a possibility of some malicious attempts or attacks. So there are two model ownership resolution schemes apart from this watermarking and fingerprinting, because this is a very normal conventional method. As I told you, that these are extraction mechanism. This is not completely protection mechanism. One is called malicious suspect, another is called independent model owner, and it is also combining timestamping, as I mentioned you, that watermarking or fingerprinting. This is the only defense which can give you a kind of security mechanism to your prior work. So it means that whenever you are going for the model ownership resolution or more, then you have 2 points in common. One is that you have to identify the suspects, and if you can make a kind of list of suspected malicious or suspected entities, then you can make a fine tuning, some kind of mixing or demixing the noising. You can make a pruning so that you can isolate the environment in such a way that your attack can be mitigated. Similarly, you can also make a list of malicious accuser, where you can have independent model owner. You put the watermark and fingerprinting at the same time, the conventional methods which can support you in the extraction of the model. If the model is stolen, then you can have the business total business model as MOR resolved. So these can be two approaches at the same time, but this is not the the fastest, or you can say smartest approach in reality. So if we can we can differentiate these two things in a two way. One is called ownership revolution versus other security and privacy concerns. You can see that model aviation, as I mentioned you what is aviation, that model aviation means that there is some slight changes in input in your training data and your output will be compromised. So what will be your defense strategy? Defense strategy should be the adversarial training, so that we will put more watermarking on the training sites, rather not opening it to the people which can be maliciously attempted, or instances which can be maliciously attempted. Then training data reconstruction. So training data reconstruction, that means that every time this data has been manipulated, has been changed. So differential privacy is one of the defense strategy which we can apply for these machine learning models to protect these kind of attacks. Then membership inferences, there is a different kind of inferences in the membership, that what kind of membership you have given to the table or to the training data in terms of or with respect to the weights, that can be manipulated at any point of time, and you can make a kind of early stopping or regularizations of the of your defense strategy to protect your membership inferences. Then model poisoning, this is another strategy which also give you a kind of security relief if there is a possibilities of attacks. Now, how do you make a kind of differentiation between already investigated systems or new systems? What are the new systems? As I mentioned you that watermarking, data watermarking, fingerprinting are the conventional one, but the right hand side, these are the two things which are coming into practice in reality more than 10 years before. That is called differential privacy and adversarial training. So we need to combine the model watermarking and differential privacy. We need to combine data watermarking with adversarial training, or we need to combine three of the left hand side with two of the right hand side. So if we have to combine it, that means we need to make a kind of new algorithms out of that, so that we can use those algorithms to protect our algorithms, our intellectual property in details. So you can also have a look on 2020's paper of the great paper of Osokan, conflicting interaction among protection mechanism for machine learning models. This is a great research work, and it has been also simulated in many industries, that how these kind of combinations can be done between the left hand side and the right hand side combination. So that means now watermarking, data watermarking, fingerprinting are becoming more smarter with the differential privacy, with adversarial training, with the model poisoning methods, etc. But these kind of libraries, these kind of softwares are not available. We need to create this thing by ourselves, and we need to create the innovation or innovative algorithm out of that. So ownership revolution versus other security and privacy concern. If you can see this table, this is also an interesting table which has been created by 2021 researchers and 2022 researchers. I would like to explain a little bit here. You can see there are two techniques, A and B, in combinations. As I told you, there are many things to be combined, left hand side and right hand side, in my prior slide. So you have to look for the model accuracy, we have to look for the metric, we have to look for the efficiency at the same time for two techniques, A and B. So the researchers already have found kind of consolidated proof to implement these kind of techniques in terms of the defense data sets and some popular open data set like MNIST and or CFR 10, and they found that dataset inference, which I mentioned you earlier, which has been published in 2021, it's a model fingerprinting technique, and it assumes that the trained data on a private training data set has been accomplished. So private training data set means that this data set has been really registered by you, and owner has been verified in the inference itself, so there is a less possibility of attack. So this is a data set inferences. If you are combining two or more techniques, let's go to this slide. I told you that these three techniques can be combined with these two, and if this is there, then we need to find out what is the accuracy and what is the measures efficiency of that. And it is found that data set inference in one of those major combination which have been become very successful in a model fingerprinting techniques. Another is called radioactive data. This is called RAD data, which is a data set watermarking technique. This is another combination where to identify models trained using their data sets. So it is using different kind of training data, but in a combination. So in a combination, you can see only one data set, but actually it comprises of different small tiny data set to train the model. So it is a kind of, you can say, creating a camouflaging to the attackers, so that they become confused, then attack should not be accomplished in the reality. So ownership resolution is one of those very popular technique, that how we can measure the security and privacy concern in terms of data set inferences, in terms of radioactive data, or in terms of combining differential privacy or the adversarial techniques with the conventional methods of watermarking and the fingerprinting measures. So interaction between AI and ML defenses, it's not that we are doing the first thing of this research. There are plenty of work available right now, but you can see this table. I am taking this table from this research paper that I mentioned in IIIT 23. You can see adversarial training, differential privacy, membership inferences, oblivious training, model and gradient inversions, model poisoning. So there are a couple of things, and you can see there are different kind of defenses which have been created so far for each and every property which has been given here. So now question is that whether this is appropriate. This is still not appropriate, because you see many columns there are question marks. That means this has not been touched so far with these techniques or with this property. So every property or every technique cannot be applied for every verticals. That's the one limitations here. Another big limitations is here, that those all techniques are not being carried forward with the devices, because you might be knowing in hardware or in kind of embedded devices there are lots of constraints, constraints of power, constraint of optimization, constraint of latency, space, and everything. So we cannot apply all these techniques in the devices. Maybe some of the techniques we can approach or we can deploy, but not all the techniques. So these are the big limitations so far. So what is the factor influencing overfitting and memorization? This is also interesting capability, because whenever we found this, then we try to investigate that what was the reason why you are not able to use all the techniques or for all the properties. So it has been found that there is a kind of attributes which are affecting for this. Of course, I told you that for the devices it is something called constraints, but at the same time, if you are not talking about the devices, there will be some constraint like size of training data. If the size of training data are enormous, it will be creating problem for you if you are not using the devices, even using the cloud. Then tail length of distributions, number of attributes. If the number of attributes are more, it is very difficult to manipulate, or you can say make the control of those attributes at the same trigger of the algorithm. Then priority of learning stable attributes, then model capacity. These are all creating, you can say, creating perspective to consolidate your good model, or you can say lucrative model, which can combine all the properties and all the techniques. So these are the couple of points which have been coming so far in the reality, which can create the overfitting and memorization at the same time. So we found one toolkit called Amulet, which can give a comparative evaluation of attacks and defenses. So you can find out Amulet from the Google. They have the good source code and GitHub. So there are plenty of source code available here, that how you can make a kind of evaluation of attacks and defenses in your system, in your enterprise, in your device, in your manufacturing unit, that whether your defense strategies are appropriate enough for the AI algorithms to protect your properties. Now combine machine learning defenses without conflicts and findings. So there are interesting things here. Uh, First of all, these defense readiness conditions, it is a word which when used by the US Army, it's called DEFCON. DEFCON means that you can identify quickly the effective combination which can produce the defense using multiple attacks. So we against the multiple attacks, if you want to make a defense, as I mentioned you, that there might be a multiple attacks which can come into your system while you are running the ML algorithms or AI algorithms on the devices. So we make a kind of system which is called DEFCON, and which can produce a measure for multiple attacks at the same time. So if you can see that first of all, that we need to make sure we need to protect the training data. We also must protect the post training scenarios in some time, because post training scenarios are important for the next epoch to activate the next session for training. And if it is stolen in somewhere, or if it is compromised somewhere, then your entire machine learning pipeline or supply chain will be affected. So these are the couple of important and crucial points, that where multiple attacks are there, and you have to create a multiple measures or multiple facets of measures in your system, so that your training data, your pre-training, in-training and post-training, all should be very much secured and protected. Now the question comes here, that why these mitigation strategies didn't work good, as I mentioned just few points earlier, that why it was not working as a good combination on the devices. Because on the cloud the stories are different whenever you are using cloud for the AI and ML attacks, and if you are talking about the attacks on the devices, then the stories and the scenarios are entirely different. So it comes with the tiny machine learning, and tiny machine learning has become so popular that you can see the IMA Innovation Forum in June 24-26 last year, 2024, and it is on the Milan, so Italy. So we have a couple of good breakthroughs, that how this tiny machine learning can be used on the edge devices or as an accelerated devices. But unfortunately, they didn't mention much about the security concerns, because it was only for the to boost the tiny machine learning community. But no one knows that if there will be a multiple facets of attack on the devices, what will be done to protect those algorithms. So now the question comes that these application of tiny machine learning models cannot be created in the devices as a large language model. You can ask me why. You can see this table, that large language model is a very large, trillions of parameters, everyone knows. So we will be doing some kind of SLM. It's called small language model. Now question here, the small language models is secure? Yes. Compared to the large language model, small language models are more secured, and they are not much been attacked so far on the SLM part. And SLM part can be, can be identified as a ownership verification, as I mentioned you. You can make the watermarking, you can make fingerprinting at the same time in your SLM in a more easy way rather than in large language model. So large language model is good to use whenever you are using a big system, but if you are using a smaller device, then it will be more appropriate if you are going for SLM. So now question that, as I mentioned, that SLM cannot be compromised, but it is not true that SLM cannot be compromised fully. It has a less number of attacks of instances. It has been reported less number of malicious attempts for attacks, but they are not attack proof. So if you can see that there are AI generated malwares, of course I am talking about LLM right now, because OpenAI, in the OpenAI systems you have chat GPT, and then this chat GPT can be compromised and can be hacked at any point of time, and AI can generate good number of malwares as well. So I mentioned the LLM here, but I'll show you some instances where SLM also can be compromised. Then hugging face attack. This is a dangerous attack which actually happens from the last to last years, because whenever the hugging face is becoming more popular to distribute their libraries, so there are more attackers seeming to reduce the efficiency of this. And then it's a excellent security and best practices which Hugging Face have, but still the attackers are trying to make a kind of repository model to upload that initiates a reverse shell with a bad IP address and allowing the attacker to access the model compute environment. So you see the Hugging Face has taken good measures to protect the libraries, but still those libraries, those models, those frameworks can be stolen or can be compromised. Similarly, data trojans in DRL, and this DRL, I mean, in the DRL scenario, the deep reinforcement learning scenario, still there is attack. And surprisingly, reinforcement learning scenario has less amount of data in terms of training, pre-training models, but still they have reported some attacks, and they use poisoning attacks. And this poisoning, as I mentioned you, that it can just deviate your input data or training data and impress the output considerably. So then you have generative AI prompts. So these are the instances where you can find out that adversarial self-replicating prompts, which can give you the Gemini or ChatGPT or Lava, cause the model. And additionally, these input compel the agents to propagate new agents by exploring connectivity within the GenAI ecosystems. So these are the rack poisoning and the flow steering. So these are the new terms which can come into the attack scenario in the form of or with respect to GenAI. I mean, generative AI worms or generative AI attacks, you can have these two very crucial methods where the attacks can be arranged or attacks can be prohibited. One is the flow steering and it's called rack poisoning. And then there are some agents which is very much crucial and becoming a great noise for whole user community. One is the custom AI agents built to translate natural language prompts into bash commands using anthropoid Claude LLM. The prompt is something like this: access desktop using SSH, and SSH was successful, but the agent continued by updating the old Linux kernel. So you can see even the prompt has been compromised. If you are sure that your LLM model has been good, has been secured, has been protected, you are not very much protected so far, because your prompt also can be compromised. So prompt can be compromised in the form of prompt injections. Everyone knows that prompt injection is another popular thing which can happen for SLM, which can happen for large language model, which can happen for mobile devices, to pick the sensitive information or to perform a task in a manner not prescribed in the applications and the attacker benefit. So manipulation of a valid user's prompt in order to cause the LLM to take an unexpected action or cause irrelevant output. So the objective is very simple, that try to deviate the output or try to deviate the training or input data in such a way so that you can deviate from your output which you have been desired so far. And these are the prompt injections effort or indirect prompt injection. These are the couple of instances which are really alarming so far. And particularly there is no method, there is no single method which can give you a protection. I will show you some of the methods. So there are different examples of prompt injections attacks. And if you can see the prompt injection attacks, then the prompt is something like this. It's an NLLM integrated application for automated resume screening. This is the use case. And the target prompt is that does this application have at least 3 years of experience with PyTorch? Answer yes or no. And then resume text of resume. And then you can see there are different kind of injections of attacks can happen. And if I just give you an example, there is escape character, there is infect ignoring, there is completions. So each and every injections has a different kind of input, and primarily it looks very small, but whenever it produces the output in term after processing the prompt, you can see the entire output will be deviated and will be manipulated at the user end. So now the question comes that what are the prevention from the prompt injection both for the SLM, small language models, and the large language models. Prompt formatting is one of the way that LLM are surprisingly sensitive to formatting, and we can make use some structured queries to do this, and we can use the old fine tuning model. As I shown you in the previous slide, there is a fine tuning methods or pruning methods which can do or which can help us to make a prompt injection. As I also mentioned that there is no single method or single security mechanism which can give you protection, so we can try different combinations to these kind of attacks. So now the question is that we can protect the generative AI data access permissions, which can prohibit some of the attacks, not all the whole, especially if you can make the version and the group name and the owner name and group permission in a good way. At least couple of these factors can be give a good access permissions, then perhaps the attacks or malicious attempts can be minimized. But it is not possible that we can make all the parameters to be controlled by ourselves, because you know that the kind of training data, the kind of size of the training data can be modified any point of time, and you cannot make a kind of pre-access control to anticipate those changes on the data side. So it is not possible, but at least the owner name, versions, then group permissions or user permission, if we can control, then perhaps some of the trojans of the generative AI, some of the injection prompt of the generative AI can be mitigated. So these are the anticipation. You can try it. So what is the loopholes in normal Llama CPP deployment design? I have found that there are a number of loopholes, and I tried to get some of the code snippet for you for this talk. First of all, that we can get a pre-trained Llama models from popular open source transformer like Hugging Face. As I told you, Hugging Face has a very protected and measured environment, but still there are some attack prone situation. So now question is that we need to take a kind of transformer for Llama from Hugging Face. So if you are talking about Hugging Face, then we need to select a model which are really attack proof, not attack prone. So if the model is attack prone, even it is from Hugging Face, we should not consider it. Then there is a kind of optimization. Now question is that what is secured optimization? Secured optimization means that you have number of, as I told you in the last slide, if you have number of size in bytes and number of data last time modified, number of collection name or object IDs are verified. So if these are maintained till your prompt has been processed, then it is called optimized Llama models. So we can check these parameters before and after processing, so that we can accomplish or we can achieve the optimized Llama models which are quite secured. Another is that deploy the model to a variety of applications or architectures. So now question is that these interfaces are not protected or protected. This should be questioned and this should be investigated. If this model are given to the various applications, suppose for example, if you are trying to make or trying to use Llama for a resume processing framework, as I showed you earlier, then we need to test the interfaces which would be giving the llama as a base or as a support, so that those interfaces should not be compromised or should not be hacked or should not be attacked so far. If those are attacks, then perhaps your secured optimization or your good transformer model cannot help you out. You again be compromised at the end. So these are the couple of things that how we can make the llama models or llama basics to your devices, because we are talking about devices, and these secured optimization also require good access of quantization, good access of operator fusions. So these can affect to your fine tuning of the generative AI data access permissions as well. So all at the same time, the end application is very crucial, that if we are not selecting a good transformer model, if you are not following the good secured optimization model, and if your interfaces are already compromised, then as an end user, as an end output in the mobile devices, you will be compromised. So only giving a shot for the ML and security measures and giving a, I mean, custom algorithms will not be a solution. Then we will also use the llama guard, because llama guard is one of the prompt injection guards into their model architecture. Some open source model introduced this, which is quite impressive, and it is a PyTorch fine tuning they have used, and we have found that these guards are quite good enough to protect a kind of malicious attempt for the injection prompt mechanism. So if there is a attempt to give you a false injection in the prompt, then probably this llama guard can help you out, but we need to very much selective for the open source model, and we must investigate the good prompt injection guards, whether they have been deployed so far in the model. Then llama guard, let me give you a very brief thing, that llama guard is nothing but it is a kind of protection in your prompt code or prompt processing code. And if you can see the code, then it is a very simple code, but there is a, if there is an unsafe content, it can be identified. So llama guard is a guard, you can say is a guardrail, we could call it guardrail. So we call it guardrail. So guardrail is a llama guard, some kind of mechanism which can keep the AI application uh, by an heuristics. So there is no kind of proper algorithm. As I told you that use case can be different. You can use the same llama model for different kind of applications. So it is a heuristic, and based on the heuristic, you can probably create your llama guard in the prompt script, and then you can make a kind of function call so that this can be protected. So if this guard is there, so at least there is 70% less chances of attacks and 70% less chances of poisoning. So you'll be getting a good output at the end. And then secured plugins, I will be giving you, or I'll be advising you to follow certain amount of mechanism of these parameters, like model path, like prompt, device, maximum tokens, top and top P and echo. So these are the parameters which are essential, but at the same time, if we can maintain these parameters in a trusted way, like we can use a good model path, secured model path, we can use a good prompt, we can use a good device, maximum number of tokens in terms of the model's response, if we can anticipate it in advance, then we can have a echo mechanism to determine whether model used includes the original prompt or not. These are the couple of secure plugins, I can say, for your model. But it is very important, the three before parameters which I showed you earlier, that you should get a good transformer, secured optimization, and trusted interface. So these are the couple of basics, and then you can have a kind of small language model playground like Conda, and you can install the Conda, and you can follow this guideline, and you can activate the environment by sending the command, and after sending the command with the Conda, all these parameters, these secured parameters which I have shown so far that can be activated or that can be written, and then you can run the llama.cpp in the Python extension environment. After that, you can have the llama based model for secure development. So for secure development, say from Hugging Face, we have I have taken J578 beta, which are helpful assistants, and we can download this very small size 4 GB at the same time. And I told you that model and the path is very important, so copy the path carefully. Then if you can make a kind of careful parameter selections of these couple of parameters which I have shown so far, then you can have a very secured LLM based model on your device. So this LLM based model on your device, if you are following this grammar and the protocol, then it will be less affected, and it will be giving you the trusted output which you have been desired. Then you can start implementing this, and then in the implementation part, the most interesting is the to understand the generative graphical model, that is GTUF or GTML, which is a C library. So it is not a Python library, it is a C library which will give you a good support for your binary format to distinguish large language model in a consumer hardware. And it is also a protection sort of thing, as I told you earlier, in this generative graphical model in GGML, there is a memory protection unit. So I told you in the initial input that there is a memory string. If you can remember well, there is a hardware and software co-design which can protect your memory. And then those kind of architecture, I can show you again the slide to recall and to flash you back, so that you should not forget anything. So these are the things which I showed you in the initial input. You can remember in the trusted computing block. Let's go just one moment. This is the MPE. I told you that this hardware assisted memory protection. The same hardware assisted memory protection are here whenever you are talking about this combination of creating llama into your deployment architecture and installations architecture or GDMU. So these are the couple of interesting facts where you can use secured model in your device, and there is no hard and fast naming algorithm that I can give you or I can suggest you. These are the things which can give you a trial and error basis. And then after the implementation, you can have a driver code, and after the driver code, you are here, and we can use that llama CPP, which can optimize the parent model to infer purely a CPP based environment. So it should also correspond to your Google computing environment and Google computing platform, GCP, also Google computing platform and Google computing cloud as well. So first of all, that we should select a good model of transformer, good secure optimization parameters, list of parameters I showed you, as I showed you already, that those parameters are important to give a good selection of development algorithm. And after that, you can have a kind of trustworthy code for your devices. So these are the checking for sensitive leaks. You can see still there are some good instances where people are saying that the Mistral models and other things are very much attack prone, and they have been given different kind of attack sensitive behavior or attack leaks whenever they are trying to compare. And believe me and trust me that they are all using so secured models, but still there are some kind of leakage and some kind of attack. So it shows that there is no hard and fast secured algorithms. So you need to try the combine and multiple combination and measures to give you the protection of your algorithm so far. Another interesting thing right now, what we are using so far, that the differential privacy. Differential privacy is one of the mechanisms which are being used so far for the health care perspective. The idea is that we should mix some noise deliberately to the input data and try to extract the noise at the output whenever the entire flow of the system or entire supply of the system are not being compromised. So this is the use of differential privacy, but differential privacy nowadays can be good use in the DNN, deep neural networks, and it has been showing a remarkable progress, because primarily there is no attack reported directly on the differential privacy, but what is concerned is that differential privacy given a kind of privacy loss, because during differential privacy is a machine learning based security mechanism, so it is a gradient descent methods, it follows the gradient descent methods, and you all know that whenever you are following a stochastic gradient descent, there will be always there could be a loss which can be anticipated, and the input vector and the turning the model not to produce the training data as output. So it is quite anticipated and quite preambled, so we cannot give solid and consolidated strategies to make differential privacy without any privacy loss. So this is only a concern, but differential privacy is a good mechanism if it can be used judiciously in the form of generative AI or in the form of SLM on the device side. And differential privacy also do not require much of the source code mechanism. It is a very small code which can be easily arranged or easily occupied on the device itself. So there is no kind of latency sort of thing, but only concern is the privacy loss, which we have to take care of. Then can models secure models? That is another big question right now, that the model can secure the models. If there is some model which can be trained and retrained on the email communication from an organization, and it can learn all the valid emails, it can learn all the malicious attempted emails, and then try to protect your model. But it will be very costly enough if you are talking about this kind of model to model training on the devices, because there is no enough space, enough memory to train your model, and then with the trained model you have to protect your own model. So there might be a big revolution if we can assess these phenomena on the device side or on the hardware side. But of course that can be done, that if we can train a model which can protect our own model, and this model can anticipate all the good or all the bad or you can junk sort of thing, and then it can classify the junk aside, and it can give you the pure and trusted information as output. So that can be possible. But last but not the least, which is the threats of running ML model on edge devices. So far we have only discussed the verticals and the you can say artifacts, that how to develop this LLM or how to develop generative AI or deep learning on the device side. Not the deep learning in details, but at least some of the aspect of the llama CPP or generative AI or prompt AI on the device side. But we can also have some threats and attacks whenever we run the machine learning model on the edge devices, because as I told you, in tiny machine learning community has no idea that what kind of different or multiple attacks can come into the reality on the devices. So first of all, that what are the possibilities that there can be unauthorized access, means that leakage of data collected and processed by ML model and ML model itself. API vulnerabilities, this is a tremendous problem right now, that leakage of sensitive information with your data and credential can be misused. Entire possible public services can be kind of victimized of these API vulnerabilities. Then cloud storage breach, then there is a kind of breach in the access to the cloud stored ML models, where backup, recovery and log access can be breached. Then model interruption and tampering, as I showed you in a different way, that how this model interruption and tampering can occur. And then there is a popular term right now called active man in the middle, MITM attacks. This is very crucial attacks where you are talking about reinforcement learning with human loops. Like right now, many chat GPT are using this. So your chat GPT prompt injection can be biased at any point of time with misdirections. So that could be an active man in the middle attack. Then reverse engineering and firmware vulnerabilities, which are directly questioning the trusted execution block, as I showed you earlier, hypervisor, I showed you earlier, SFM, system management mode. And then scalability and interoperability issues. This is a problem because the devices are not that much scalable, because each and every mobile version, you are very much aware of this, that each and every year Apple is coming with different kind of iPhones, different kind of versions, cameras and resolutions, memory size, acceptability, etc. So this is a big issue to give a leaps and bounds effect on the algorithm side of the protections. Then side channel attacks and resource constraints. This is a crucial thing for our edge devices, that we have the side channel problems of logical characteristics of edge devices, of power consumptions, then electromagnetic leaks, timing information. These are the issues for the side channels. This can be a big thing for the TinyML as well. Then limited network connectivity. This is a great problem in the rural areas where the internet is not that much conversant with the type of connectivity established in that region itself. So these are the possibilities where there will be some impact on the attacks with the tiny machine learning, or mobile devices will be compromised with the machine learning algorithms. Then we can have a kind of cryptographic solution here with an executing ML apps on devices. So we have to have some acts before, and we have to some acts after. Before means that client app sends request, then backend executes ML model, then backend sends ready results and repeat every time. This is the before things. And after that, after things is that post operation is that client app sends request, backend generates unique individual ML models. This is very important, IML we call. Then backend sends IML to client app, then client app stores and execute IML locally, and IMLs are unique per user. So this is very important in terms of security, that whenever you are generating one IML for user, it becomes a ownership verifications done. So nobody can duplicate you, nobody can replicate you, and there will not be cloning anytime. Any possibilities of cloning have been mitigated here. So this can be one solution, and most fortunately there are tech stack available for this, that you have mobile apps, then it can be in the iOS, and then Core ML, then Android also, Kotlin and TensorFlow Lite can be used. Even Execute Torch, PyTorch has a variation you might be knowing, that is called Execute Torch. Execute Torch is very much good in for the IoT and the edge devices for PyTorch development. And then you have the Python environment, TensorFlow, then you have Google Cloud Computing environment, Google Computing environment. So these can be and also Firebase, this can be a good tech stack to develop these scenarios for the crypto solution for your ML, if it is running on the mobile devices, not for the all mobile algorithms or machine learning algorithms, but some of them. So architecture and data flow should be like this, that we have a native iOS app, and or we have a native Android app, then we have the API, and this API has been protected here. You can see that we are generating 1 ML per users, so it becomes unique, it becomes identity verified at the same time or at the source. So there is less possibility of cloning, or less possibility of duplicating your uh, machine learning model at the output. So these are the life cycle of IML, which is quite interesting. Then you can see that the right hand side, which is quite I mean crucial and impressive parameters. So it called memory transit, storage transit, only transit. So this means that however, if you have a transit, every time there is a transit, so of course there is a kind of optimization issue, that you are trying to switch or interact between different kind of different kind of endpoints. So if you have different kind of endpoints in divide, and if you have multiple number of transits, then of course it's not very much encouraging for the edge community, because edge community requires minimum interaction, so that energy and other constraint can be optimized at any point of time. So but the most good thing is that, the most interesting and impressive and significant fact is that this IML life cycle is not delegating any kind of hazards to any of the device or any of the algorithm itself. So they are completely running independently, and there is not much complex encryption mechanisms. So processing speed is processing consumption speed and the processing memory speed is quite low and quite under control. So this can be one thing. And then uh, whenever you are making a full encryption uh, with the support of the cloud, because there will be service provider, there will be operators, so we cannot escape those people out of the cycle. So they will be in the loop. So they will be in the loop, and you can decrypt your IML, you can encrypt your IML at the same time on the devices itself. So of course you have to take the Google computing environment partially, not fully. It should not be independent on the hardware side itself, but it is not a I mean insignificant solution at this point of time. So one solution can be that you can protect your I mean machine learning models or machine learning frameworks which is running in your mobile device with an encryption, basic encryption, not big encryption or complex encryption mechanism, only to encrypt your API. And as you are producing one machine learning per users, so there is a kind of limitation not to be cloned or not to be compromised at the user end. So what is the takeaways which can be the expected? First expected is that generative AI is not a deterministic computer program that will behave within expected predefined parameters. As we all know, we need to use some kind of stochastic and some kind of mechanism of AI. I'm not too sure that what will be the future of generative AI, because everyone is looking for generative AI, but generative AI is not the thing which is quietly trusted. Then we need to use guardrails, because without guardrails we cannot protect our engine, our prompt. We must have some data governance mechanism, because this is a scenario where the legal and ethical AI should come into play, because each and every AI operation should be ethical and should be legal. There is a global argument right now that the data should be compromised or not. Whenever you are training your model, you need data, and if the data is compromised, then data government should be treated as a failure. Then certify the authorship, which is very important, that who will be the owner, who will be the verifier, who will be the proprietor of the data, who will be the proprietor of the authorship. So these are the couple of things which will be coming as an enterprise or as a developer whenever you are talking about mobile machine learning development or device based machine learning development. So what we are trying to do, we are trying to create a certain amount of innovations here. One innovations we are trying to use that some kind of hardware neural network, which we are doing right now for last 1.5 years. So this hardware support for activation function is the ReLU, Sigmoid, TANH, and Swiss H. And this hardware neural network is an interesting fact that they are using small kind of capacitors and small kind of hardware unit, which can be really installed and embedded in the device itself. And then another is called another mechanism we are also trying to look is event based variational Thompson sampling for model based reinforcement learning. This is a kind of new strategy to protecting your machine learning algorithm from security threats. So whether we are making a kind of continuous sampling, variational sampling in the model based reinforcement learning, so that no one can really anticipate that which kind of actual reinforcement learning model which been used for the policy or for the verification of mechanism. Another is that the secured hardware neural network model, which is called HNN, which we are trying to implement right now. We are in the stage of developing this in terms of creating open source libraries. And the most interesting fact is that we are trying to reduce the energy cost. We are trying to eliminate the circuit redundancy compared to a big microcontroller. So the big microcontroller, the cost, the efficiency, the occupancy of the memory units are tremendous, which in comparison of hardware neural network will be very tiny. And then it should be limited latency. That is also an interesting thing. And most interesting right now is the on-device continual learning with binary neural network. This is another interesting thing we are doing. Binary neural network is only the neural network which can give you the only +1 and -1 or 1 and 0. in terms of classification. And as the devices are having many constraints, so these kind of binary neural network on continual learning can be helpful if we want to develop a kind of secure strategy on the device itself. So these are the couple of things. And last but not the least, I will show you a report of Apple, which is pulling January 16, 2025, a couple of weeks before, I think. And it is showing that Apple is pulling its AI generated notification for news after generating fake headlines. So you can see that all these notes, all these messages is coming that they have been withdrawn. Apple is temporarily pulling its newly introduced artificial intelligence features that summarizes news notification after it repeatedly sent users error fleeted headlines. So that means they have been compromised and they have been attacked. So these are the couple of instances still are going on, and we are not able to control those instances. But hopefully, I'm quite hopeful that within couple of years we will be having a full control of it, out of it. I mean, there will be less number of attacks, and if there will be less number of attacks, it is sure that these kind of compromises of injections, prompt, or you can say untrusted scenario verification mechanism, all should be more pure, all should be more trusted and worthy to discuss. Thank you so much for your attention. If you have any question, then you can have a shout or
Mhm. Okay, perfect. So super interesting, and it was a really large spectrum of topics about the super important topic of AI security. So thanks a lot. Let me just hide this one in our joint view. Okay, perfect. So yeah, really nice, because it's such a super important topic, and you really managed to cover so many aspects that was very good. It was really going around.
yeah, my objective was that we should start from the basics, that and I was showing some kind of instances where I was trying to make some hands on, that before going for the real Llama CPP or secured plugins. That is very important, that people are not knowing that what will be the secured plugins. And there are many frameworks available right now in the market commercially, like as I mentioned, Hugging Face, Mistral AI, but all are having different kind of loopholes. So we have to create our own algorithm, own strategy to make a trial and error. There is no deterministic method to apply this.
Mhm. Yeah, good, very good. So it's there are so many points to start. Maybe let's revisit some of the concepts you looked at first, to really make sure
Yeah,
the people got
yeah,
the
sure.
get the point. So about the watermarking. So what would you watermark exactly when you use AI? Where would you put the watermarks, and what would they look like, and who could do such watermarking? So which entity
Uh,
would be doing this? Is it a state
uh,
entity? Is it a service provider? Is it the
yeah,
user? Where's attestation done, and so on?
yeah. Watermarking is of course an attestations, and if you are talking about the who will do it, the watermarking can be done by the service provider. It is a dual end scenario. It can be done by the service provider itself, or it can be done by the developers, because whenever you are using developing a stack, then you can make a kind of two models. One is the watermarking, and is called fingerprinting. So if you are putting an watermark, or you can embed the watermark, then probably your ownership verification has been justified. Say for example, graph neural network. There is a paper I showed, Grove. It is a very famous graph neural network paper which has been published in 2023, which shows that embedding is a property. If you can use embedding in the graph neural network, so each and every graph neural network has a unique embedding. So that means nobody can duplicate, nobody can replicate your embedding in terms of malicious attempt. So that can be one thing. So it means that it is a dual. You can produce in the algorithm as a watermark, as a function, or as a service provider. If you are a service provider, you can put an watermark to register and to verify your own model.
Mhm.
Now there is a question, what is the cost? Because many people ask me about the cost, because if you are talking about the watermark in the service provider domain, say for example, you are talking about the eSIM or connected SIM or eSIM for IoT network, and I am the service provider of the eSIM, should I give the watermark to the eSIM? That will be a costly effect. So of course it will be a costly effect, but if it is a kind of watermark from your service provider, your service have been value added. So nobody is saying that your eSIM is without protection. You already have been watermarked. So eSIM marked by mark has been marked by yourself. There is no one which can duplicate your eSIM. So I am taking money out of you from you, but at the same time I am giving a value addition to you. So it is a dual purpose. You can put the watermark as a developer, you can put the watermark from the service provider. And most importantly, watermarking and fingerprinting, pruning, fine tuning, these all methods can be done with a good strategy of reinforcement learning, because this comes under policy. That if you are very much strategic and deterministic, that this is my policy, this is my headwards goal to protect my machine learning model in the device for the end users, then I can create a policy by my own with a reinforcement learning strategy. I can put watermark as a function, I can put a fingerprinting as a function, and try to create the owner verification at the end. So it can be covered in the reinforcement learning itself.
Mm-hmm.
So it is a business model, of course.
Mm-hmm. And okay, very good, and also very good that you covered again quite a scope of topics. And regarding the attack scenarios, you were showing different attack scenarios like prompt injection and so on.
Yes, yes.
But the watermarking itself is rather for the model. And if the model would be changed, could you describe what the attack scenarios from the literature are? So what exactly do they expect will be the effects of modifying the model?
If there is, I showed you that there is a point called model inversion.
Hmm.
Suppose you have created one model and in effect some other model have been shown in reality. But frankly speaking, there is no kind of mechanism to protect model inversion if the model has been modified or changed at any point of time.
Hmm.
So question is that if somewhere down the line the model is stolen or model is changed, what are the impacts? So you, in this case we are not going to the cause. We have to show the impact. We have to detail in the impact. Impact is that, for example, I am using a logistic regression model or support vector machine in a mobile device. Can I do that? Question is that if I can do, probably my algorithm will fail, because support vector machine has a lot of computations which my device cannot support or may not support. So obviously the impact is that in the output is deviated, or output not at all giving any kind of classification mechanism which you are expecting.
Hmm.
So if you are asking me that is there is a strategy to give a counter method for model inversion, there is no strategy.
Hmm.
Model poisoning, prompt injection, there are many strategies which you can. There is llama guard, there is guardrails, you can have a lot of protection in the script. But if the model itself has been modified, you cannot do anything at the input end or at the developer end. You have to show the output end. That means the post training scenario is very important. As I told you, that is a multiple combination, def con defense, that there will be multiple combination of defense. So
Hmm.
this is one of the defense that you should be not be very much happy after the end of output. You should still make a good watch on your output itself. So the post training scenario is also very important.
Hmm.
Post training scenario can give you the idea that what kind of model has been modified, what kind of model has been inverted, and what are the effects of your output which was not desirable.
Hmm. Okay, and so to put it in other words, if for instance you use a large language model to learn the control of your factory, then obviously if the model is changed, then there might be an unexpected outcome. If you
Yes.
think about text generation, it might be less obvious because it might even create garbage or something like that, but you might want to introduce some wrong facts or stuff like that. Even though I think this is way more far-fetched for this changing the model, because it's not at all obvious how you could get in fake facts easily to a model. Okay, cool. Then another question is that's a bit independent from your talk, but also super related. So all your mechanisms we were talking about were rather about traditional AI training and usage, which means the thing is running in the cloud, and then afterwards you're
No,
like
no.
protecting it. And you were also talking about the small language models which you can
Yeah,
train
yeah,
locally.
yeah.
If I understood correctly, with the DeepSeek, the model is, and also the reasoning thing is small enough that you can run it even on less powerful computers. Would you, from your experience with the technology, would you say there is currently a trend starting towards local execution and local storing of the model, or is it
Exactly,
rather?
exactly. That's why DeepSeek has been given as so much buzz noise globally, because they are executing the model locally. But there is a big question here that they are not very much transparent with the training data, where they have run the training data, whether it is a private server or whether it is a kind of data protection protected server. This is not clearly written. But
Mhm,
anything and anything comes in the future. Probably OpenAI should also think about it, that there might be some model who should come to execute locally, because
mhm,
people are very much curious that what is happening locally. They are
mhm,
not very much curious what is happening in the cloud. Even if it happens in the cloud, it is out of your hand, out of your control. But
mhm,
if you are executing locally, cost and the other parameters are really mitigated and really under your control. One
mhm,
thing is this. Another thing is that this is very much important, that neither OpenAI nor DeepSeek are given a prompt thing for the security purpose. They didn't mention anything about security.
mhm,
You see, in OpenAI, also in the chat GPT, there is no kind of source mentioned, that from where that source has been accused for. What is
mhm,
the source of training? They didn't mention. So
mhm,
this is a kind of tremendous alarm for the security part. And if you are talking about SLM, small language model on the mobile devices, still you will be a owner of the devices, if you will owner of the training data. So you are not concerning about the Google Cloud. So
mhm,
whenever you are going to the cloud, you have been sold. Your identity has been completely sold.
mhm,
So these are the advantage, but DeepSeek model has not been proved so far in terms of security. Even OpenAI, same thing. So
mhm,
they are not very secured.
mhm,
It is 100% sure they are not very secure. But
mhm,
it is quite sure that local execution model are becoming very, very popular. People are going for it, and the attacks, the possibility of attacks in local models, local execution models are less.
mhm. And this is also why I loved your talk so much, because as it's a still quite new technology overall, security was not the first-hand interest, because it was rather creating a proof of concept. And it's I really love that you showed so many aspects of the security, because in the end, the pipeline is rather complex, and also the attack vectors are rather complex. But at the same time, there are things
But
that
but
can
but
be done.
but big question, Mark, big question, very common question. Whenever you are going to the market to acquire something, to purchase something, do you not ask the shopkeeper or the owner that it is secured, it is good, it is protected, not giving any kind of harm to my family? It is a normal and general question. So whenever we are trying to develop a proof of concept, it is a generic thing, and it is a by default sort of stuff that we should think about security at the same time,
Mhm,
not in the holistic way, but at least in some way or others, that we should think about security, that whether it is primarily secured or not, especially for the training part. If we are making a training data which is fake, obviously my output should be biased.
mhm. And so, I mean, of course, I fully agree with you, especially as with the AI and large language models, it's already quite mysterious in some sense how what the outcome is. Not because the steps are not explainable, but rather because there are so many complex relationships taken into account, that the risk of an attack going undetected is significantly increased, I would say, because it's very difficult
True.
to 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 see that it was attacked. because between the input, because the only part of the input is known, because the model is not known in the sense that you know all input and so on, and so you only know what you put in, then a massive amount of things comes in through the trained model, and then you get an outcome. And if through all the steps you said, there can be manipulations, and
Yes.
for the human user or also for the automation, it's not at all obvious to detect something afterwards, and therefore it's super important to indeed project the steps so that it does not happen in the first hand. So I fully agree with you. And so,
Because I am telling you also the instances which is very relevant here. The I mean, before 20 years down the line, there was no LLM. There was called natural language processing, NLP, and NLP is the genesis of this large language model. And whenever we use NLP, we never thought of NLP will be used as a commercial purpose. We thought NLP can be used for the generation of book, generation of guideline, generation of storybook, generation of playbook for the kids. But we never thought that NLP can be used for a chat GPT. So the genesis, the theory of LLM has come from the computational intelligence, which is called natural language processing. But natural language processing gives a natural language. I mean, noun, pronoun, verbs, articles, identifiers, etc., prepositions. But they didn't say that it could be commercially used. Now it has been commercially used, so it is the high time to give a thought for the security.
I fully second that. So as the time already advanced, so what, maybe a last question. So how mature would you say are we at the moment with the use of AI? Would you say it already started to maturize a bit because now security is added, or would you still say probably
Yeah,
we are still somehow in the
security has been added so far, because I have seen the people, the good companies. I mean, from Samsung, from all other the tech companies, they are providing a lot more emphasis on the security. Especially there is one company called H Cortex. I should mention their name. It's from Japan. So they are also doing a good secured accelerator. And now, but only the question is that this security and this AI accelerator on the device side, on the mobile device side, are not fully proven. Fully proven means they are not given in a great adversarial environment. They are not given in an attack prone environment. And the instances of the testing of those security are very limited. So you can have only 100 instances. So 100 instances cannot give you the foolproof guarantee that it has been fully secured. So I am telling that it is taking some streams on the tiny machine learning on the devices or edge AI, but I cannot say it is fully secured. And even a couple of years before, there is a private blockchain development. When I did something on the private blockchain stuff, I did make some kind of PUF, secured PUF, physically unclonable function, which has been protected by blockchain, but it has not been fully proven, because it can only prove 2 or 3 instances or 2 or 3 use cases, but it cannot be a generic theoretical saying that it has been fully proved. But it is hopeful that now people are talking about secured AI. Now people are aware that my identity uh, cannot be verified at any point of time. We can be sold, we can be caught, my bank can be empty at any point of scam with any scam. So all can be generated by AI. So people are aware of that. This is good thing, this is a hopeful thing. And if people are aware, then of course the technology should be there. If people are not aware, people are not conscious, then technology cannot give you any kind of hope.
And I think
Technology can be a bliss, but it cannot be a boost if we are not concerned.
And I would say this is exactly one of the big values of your talk today, because you made the people a bit more sensible of what could be potential challenges and what could be
Yes,
potential solutions for it.
yes.
Very good. Cool. So big
Thank you
thank
so much.
you. It was really a great pleasure having you, and it was a really nice talk. So really thanks.
Thank you
Thanks.
so much, and I'll be looking forward to working with you very soon again.
Perfect. And so for the series, so the next edition will be on the 7th of March. So
Yeah.
we put it 1 week later, and it will be on hacking innovation, and it will be about why security needs patents and vice versa. So the working title, but it will be something with patents. And we have a patent attorney, Christian Moore, with us, who will be talking with us about that. Also a super important topic, because patents are very important for cybersecurity.
Very important, very important. Intellectual property protection is very important.
Yeah, and at the same time, it's also one of the topics that are not so much looked at. So yeah, very nice. Okay, cool. So yeah,
thank
then
you so much.
join everybody on the 7th. And yeah, for those online, I show the outro, and see you. Stay safe, and until
Thank you.
Cher CyberCNI, pôle d'excellence région Bretagne. Au revoir et à la prochaine.